Hi, welcome to this early demo on the BIMWERX connection tool. So you can see we've got the connection modeler open here, and we'll just open up an existing model, and as you can see it's an Excel spreadsheet, so you can drive this from any external source, or you can manually enter the model components that's going to make up the steel connection. Now I'll just quickly show you how this works. So we've got different sheet tabs there at the bottom. This is the profiles one, and this links through to the BIMWERX FEA section library, and you can obviously choose from any of the parametric sections, or if you've got custom sections defined in here that you've created in GenFEA using the section designer, they'll be available. We reference them in the profile sheet, and we specify their start and end positions and rotations and some other parameters. Then we've got plates. So plates are elements that we define in the plate sheets. We can create bolts. And in this one, we don't have boxes. You'd have a box when you've got a, let's say, a foundation detail or a base plate detail maybe. We create some planes, and I'll just switch them on the model here so you can see. So if we turn those values for visible to yes, then we can see those planes, and we'll use them to cut some of those elements for the haunch connection in this particular example. Then we've got a sheet for cuts, and we can use elements to cut against. So if we use the face selector, we can get the ID of the element plus the face number, and we can cut that against other elements. So we can also select elements in the model, and that'll give us the entity name, and we can use that to cut elements either against each other or faces, or against the planes, the cut planes that we created earlier. So by using these tools, we can pretty much create any type of connection. Now the idea is to create some templates in the future that we can use to help you get started and get off the bat quicker. Now the first step is to do a pre-processing, and this is going to generate some 2D meshes around some of those components that we're going to use later to extrude and create our hex mesh. For non-uniform elements where we have to generate a complete volumetric or a hexahedral mesh from scratch, we have another tool that will do that. So this is sped up quite significantly. The overall process here took around about 10 minutes for the complete hex mesh model generation, but it's fully automatic, and obviously this is quite a hot topic in how you achieve a high quality hexahedral mesh automatically, and it seems like we've been able to do this reasonably well, but some further development is underway to even improve that further. So you can see here we've got a pretty decent quality hex mesh for all those elements, and we are now in solid FEA, which is going to be connected to the BIMWERX connection tool or the connection modeler tool, and we can just switch some things to transparent to see what's happening there in the background. And of course we've created automatically a whole lot of surfaces that we can use to either weld to other parts or to use as contact elements or apply boundary conditions to. So you can see that's automatically generated by the modeler. There are some errors there at the bottom. We're still developing this. It's in really early development, so don't pay too much mind to that yet. And then of course there's also the material and section properties that's automatically been assigned to all of the connection elements that you see there. We've also set up some hard contact surface behaviors, and again this will be fully automated in due course. So once all of that is set up and we have defined all of our boundary conditions and set up all the contact elements and connections, the ties, etc., then we can go ahead and look at the results. So in here you can see we've got all of those ties set up, we've got all of those bolt elements connected, we've got the plates contacting with the flange of a column, and we've got some boundary conditions. So here we can see we've got a fixed support at the top and the bottom of the column there, and if you see that blue arrow, that is the displacement, and this was calculated using GenFEA. So we've used a general frame analysis tool to calculate the displacement there, and then we apply that in the sub-model analysis. And when we switch to the results, we can switch off the contours for the elements that we're not particularly interested in. We're more interested in focusing on that steel plate haunch connection there. So we'll just toggle the visibility here so we can see a bit clearer what's going on in the model. And Perhaps we could switch this to a solid model so we don't see all those hexahedral mesh element edges. And we're looking at the displacement here in the current view. Maybe we can switch that plate element back to opaque again, just for better visibility. But you can see pretty good symmetry there on the plate in terms of the XYZ displacement results that's currently displaying. And we can switch this and view the von Mises output, or the Tresca output, or whatever results it is that you want to obtain from this. We don't have really high values there. This is just like a silly sample model, but even though it's basic, it was not hard-coded, which means using the workflow that we've demonstrated here, you can pretty much model any connection of any complexity, but we will be building some templates, like I mentioned before, for standard steel connection types and others, and it will also ultimately connect through to GenFEA and pull values directly. We hope you enjoyed that. If you're interested to learn more, contact us. Cheers, bye.